20 years ago, on May 4th in the year 2000, a new computer worm hit the internet. Sometimes called the I Love You Worm, sometimes called the Love Bug, this worm, along with the Melissa worm the year before, heralded a new wave of internet worms. I just happened to be collecting some network data at a United States Air Force site for worm detection research when the I Love You worm swept through their site. This video shows what the worm looked like from our network sensor's point of view. First, a little background so you can understand what you are seeing. Our software looked at the data in a network connection and calculated a fingerprint to represent all the data in that connection. That fingerprint was just a single number, kind of like a hash for the computer geeks out there. But there is one difference between our fingerprint and a hash value. For a hash function, a 1-byte difference between two connections results in wildly different hash values. For our fingerprints, we wanted to be resistant to minor variations in the data, so a small difference in two connections would result in nearly identical fingerprints. So suppose Bob, down here at the bottom of the screen, wants to send email to 3 people, Spawn13 and Demon1 at hell.org, and Angel23 at heaven.org. When Bob presses send, his email client on his computer sends the email to his email server. And then his email server sees that there are 2 recipients at hell.org, Spawn13 and Demon1, so it establishes a sendmail connection to hell.org to deliver the email, connection 1. And then Bob's email server establishes a second connection to heaven.org for the email destined to Angel23, connection 2. Our network sensor sees both connections, calculates a fingerprint value for each connection, say 63.2 and 63.4. Because these fingerprints are nearly identical, we can make a reasonable guess that the same email was just sent to heaven and hell. To visually represent the data, we create a graph and animate it over time. On the x-axis is a bunch of values representing fingerprints of connections. A fingerprint of 63 or 27 or 983 simply means that these emails were different emails. It doesn't mean that one email was greater than the other. The y-axis represents the count of email connections we saw with roughly the same fingerprint value for a period of time, say within the last 5 minutes. So in our example of the 2 connections to heaven and hell, each with a fingerprint value of approximately 63, we would see a bar of height 2 showing there were 2 connections with almost identical content around the same time. If, near the same time, Mary sent a different email to 40 different people at 16 different organizations, we would see a bar of height 16, representing 16 connections to the email servers at the 16 different organizations. So the higher the vertical bar is, the more organizations got the same email at nearly the same time. So back to the data. So this tiny green blip here represents an email to one organization. Because the fingerprint is just a number, I have no idea what the content of the email is. I just know that it didn't go to too many organizations. In this case, just one. The slightly taller blip over here shows that the same email went to about 10 different organizations. Maybe the person hit reply all or sent an email to a local mailing list that then sent the email to people at 10 different organizations. And this red ball here? Well, I received the I Love You email too. Ironically, from a DARPA computer security mailing list. Anyways, I calculated the fingerprint for the value of the I Love You email that I received, and I plotted the red ball on the x-axis showing its fingerprint value. Now, one comment about the timestamp. The Air Force people who set up the computer for the data collection did not sync it to any time servers, so I don't know the exact time that the worm hit the Air Force site. But the time will be interesting a little later. So let's watch the time-lapse video move forward. So we see little spikes, probably people sending emails to mailing lists. And boom, suddenly we see a big spike of identical email connections that peak at about 460 connections in a single 5-minute window. Remember, this is an email connection between organizations. Each connection to an organization may include dozens or hundreds of individual recipients. So we are seeing a huge spike in nearly identical emails being sent out or received. And if you look, the fingerprint value for the spike, it is the same as the fingerprint value for the I Love You email that I received. So we're pretty confident that this spike represents the I Love You worm. And I want to point out the time here is 10:38. Now, as I mentioned, we cannot trust the time here, but I do want you to remember that the time is about 10:30. Now, one last thing to highlight is that there is a second spike at the same time. Because I wasn't collecting the full packet data, I don't know what that spike is about. However, because email attachments, like the I Love You payload, can be encoded in different ways when being sent out over email, my guess is that the second spike was also the I Love You worm, but just using a different encoding scheme. Now let's continue the video. And here's the second spike of the worm hitting the Air Force site, just a little less intense this time. And again, we see two spikes with different fingerprints. One thing I find interesting about the second wave of the I Love You worm is that it hits about 3 hours after the first wave. Again, just a guess because we don't know much about the computer's clock, but I think the first wave hits when people on the East Coast showed up at work and checked their email, thus spreading the worm initially throughout their organizations. And the second wave hits 3 hours later when the people on the West Coast show up at work, check their emails, and then spread the worm yet again. Anyways, there you go. Perchance, 20 years ago today, I was collecting fingerprint data on network connections at an Air Force site when the I Love You worm swept through their site. We got to see what appeared to be two different encodings of the worm payload, and we got to see two different waves of the worm sweep through the site, separated by about 3 hours. It was the beginning of a new era of internet worms.